Hi, welcome to the Geographic Information System class. In this video, we will discuss the Geographic Information System or GIS, especially regarding the definition, function, and history of the birth of GIS. We will also discuss the relationship between GIS and civil engineering. By the end of the video, you should be able to understand the definitions of datum, map projections, and projected coordinate systems. GIS can be caught on in a few faculties concurring to different forms of sources. Aaron F. 1989, notices GIS as a working framework based on spatial information that's utilized to enter, oversee, control, and analyze information and give depictions. Marble et al. 1983, argue that GIS could be a spatial information handling system. Burrow, 1986, incorporates a diverse definition, that GIS may be an apparatus for collecting, putting away, recovering wanted information, and showing spatial information from the genuine world. Apart from several theories in developing understanding of GIS, we can conclude that GIS is an information system that can input, store, manipulate, analyze, and display geographic data which will then be geo-referenced to support the decision-making process. Before discussing in-depth GIS itself, it is important to understand maps. I'm beyond any doubt you've seen conventional maps even though they are generally straightforward. Conventional maps are commonly referred to as analog maps. Analog maps are made using cartographic techniques and are printed in two-dimensional versions. This map also contains information such as scale, coordinates, directions, cardinal directions, etc. Meanwhile, GIS can be defined as a computer-based system for collecting, storing, managing, analyzing, and presenting geological data that has gone through the data georeferencing stage to support decision-making. Georeferenced data refers to information attached to a point location or place on Earth. For example, when you want to go to a new place called Chape, unfortunately, you don't know which way to go. You take the initiative to open a GIS application such as Google Maps to find the best route. When you find a place claimed to be called Mini Market A, you not only get the best route but also time and related location information according to general Earth conditions. GIS provides several pertinent information ranging from addresses, coordinates, and even elevation to ensure you get what you are looking for. If you have confirmed that the information belongs to Mini Market A, you will of course use the route feature to start your journey. This condition is known as geo-referenced data. Then what is the connection? Since analog maps are known as conventional maps, this type of map needs to be digitized to update information related to the Earth. This digitization is expected to make it easier for users to access Earth information, as well as for developers. It is used to update data and further analysis. Why should analog maps be digitized? Handy maps are not just about ease of access. Users can also get the latest information, both static and dynamic, flexible, and easy to do analysis and modeling. GIS technology is developing because it is able to develop map data and compile spatial databases so that it can replace conventional maps. In addition, the development of GIS technology is also driven by regional autonomy factors that trigger the need for spatial information for the management of regional natural resources. Some GIS support application features are more dynamic on almost all electronic devices, allowing us to visualize the shape of the Earth to be geographic information. This geographic information is part of the visualization of everyday life which can be used to support decisions based on geological data. There are several ongoing advantages to GIS technology over analog maps. GIS allows us to get a description of the attribute data contained in the map information. With knowledge of this attribute data, we can identify a map to determine the element to be described. Technically, attribute data is generated from spatial information obtained based on real Earth conditions. This information is then expressed in the GIS database according to the category. Each category in a GIS database can be divided into specific groups. For example, the school building group includes elementary school buildings, high schools, and universities. Groups of government buildings can include, for example, the area of a ministry office, a capitol building, or a tax office. Similar frameworks can be applied to natural groups such as rivers, lakes, and mountains. All of the previously described attributes have additional database information fields such as an address, area, phone number, etc. Then, the attribute data can be adjusted according to the type of map to be created. However, considering the amount of attribute data which can be very large in dimension, attribute data is only displayed usually in a certain table format to facilitate the analysis process. GIS technology is also able to identify spatial conditions to adhere to the spatial trends of various map elements. Thus, users are able to connect the pattern of the attribute data into spatial information that is adopted to the spatial data representation. Finally, this technology allows us to model geographic information through complex spatial analysis. As part of an information system, a GIS may look similar to a management information system, MIS. Is it technically correct that GIS is derived from MIS? Then, what is the difference between GIS and make it different but equivalent to MIS? As the name implies, MIS is presented to support operations, management, and decision-making in organizations. Meanwhile, GIS is presented to store and manipulate geographic information, and the presentation is done on a computer-based basis. GIS also definitely goes through the data georeferencing stage to support spatial analysis. Thank you for watching, and see you in the next course.